Hi friends, let us continue with our question and answers for light reflection and refraction. Question is, what is the use of convex and concave lens? The convex lens is used by watch repairers to magnify small parts during repairing the watch. The concave lens is used as corrective lens in spectacles for some people. Okay. Next question. A convex lens is placed at the origin. Show the coordinate positive, negative axis, etc. etc. So remember, the coordinate system is important to ensure which is positive, which is negative, etc. So you see the coordinate system here. This is the origin. Along the right is the positive x. Along the left is the negative x. At the top is positive y and at the bottom is negative y. Okay, now the lens is placed such that its optical center is exactly at the origin. Okay, so if you place an object between center of curvature and the focal, as you have seen before, a ray which travels parallel to the principal axis will go through the focal point on the other side. A ray which travels through the optical center will continue without any change in direction. They both will intersect here, and because these two rays are coming out of A, the image of A will be formed where these two rays intersect. Okay, so you have an inverted image and you have A dash B dash, that is your image. Now if you look at the object distance, the object distance is negative. Why? Because the object distance is OB, which is along the negative x-axis, so it is negative. Okay, the image distance, however, OB dash is positive because it's along the positive x-axis. For convex lens, by definition, the focal length is positive. Okay, so the image object size is positive, whereas the image size is negative. Why? Because object size is along the positive y and image is along the negative y. So this is how the coordinate system will be used. So note, for convex lens the focal length is positive. For concave lens focal length is negative. Okay, AB height of the object is positive because it's along positive y. A dash B dash, the image height is negative because it's along the negative y axis. OB object distance is negative. Okay, OB dash image distance is positive because it's along the positive x axis, and the focal length is positive because it's a convex lens. Okay, and next question, give the lens formula, describe it, and give the magnification formula. See, the lens formula is different from the mirror formula. In the mirror formula, you had 1 upon V plus 1 upon U is equal to 1 upon F. But in the lens formula, you have 1 upon V minus 1 upon U is equal to 1 upon F, where V is the image distance, U is the object distance, and F is the focal length. Similarly, the magnification due to length formula is also different. It is image height by object height, that is H dash by H, that is equal to V by U. For mirror, remember you had minus V by U, right? Here it is V by U. Okay. Next question, the concave lens, focal length 15 centimeter, what should be the object distance if image distance is 10 centimeter, and what is the magnification? Okay, they have given focal length is 15 centimeter, but concave lens, as you can see, if you draw a rough diagram of concave lens here and a rough ray diagram, and remember the concave lens's focal length is taken as negative. Okay, so F is actually minus 15 centimeter. We have to take the correct sign before we use the lens formula. Okay, so when the image, when the object is at 10 centimeter, image is between F and O. Okay, so if you remember the ray diagram of a concave lens, always the image is formed between F and O for objects which are not at infinity. Correct. So it is given that if image distance is 10 centimeter, but the image is between F and O and it's along the negative x-axis. So when they gave it as 10 centimeter, you have to say V is equal to minus 10 centimeter. Why minus 10? Because it is along the negative x-axis. And they are asking what should be the object distance. So to get the object distance, you use the lens formula. 1 upon u, v minus 1 upon u is equal to 1 upon f. So if you want 1 by u, what you can do is you can send the 1 by f to this side and 1 by u can go to the other side. When the minus 1 by u goes to the other side, it becomes positive. When the positive 1 by f comes to this side, it becomes negative. So 1 by u is equal to 1 upon v minus 1 upon f. Okay, what is v? It is minus 10, substitute for it. What is f? It is minus 15, substitute for it. This minus and this minus will get cancelled, so it will become plus 1 by 15, and 1 by minus 10 is equal to minus 1 by 10. Okay, so what is the LCM of 15 and 10? So 10 and 15 LCM, 5 2s are, 5 3s are, then 2 1s are, 3 remains as is, then 3 1 and 1. So 5 2s are 10, 10 3s are 30. 30 is the LCM, right? So to make this denominator 30, you have to multiply numerator by 2. To make this denominator 30, you have to multiply the numerator by 3. So you'll get minus 1 by 30. Okay, that means 1 by u is equal to minus 1 by 13, which means u is equal to minus 30 centimeter. Minus 30 centimeter means the object should be kept at minus 30 centimeter, then we'll get an image at minus 10 centimeter. Okay, so what is the magnification? Magnification, as you know, is h by h dash by h, that is equal to v by u. V we already know is minus 10, and u we have calculated it to be minus 30. So m is equal to minus 10 by minus 30, 1 by 3. 1 by 3 is 0.33, which means the image is erect because magnification is positive, it is virtual, and it is diminished because it is 1/3 the size. Okay, so next question. 2 centimeter tall object placed perpendicular to the principal axis of convex lens. Focal length is 10 centimeter. Object distance is 15 centimeter. Find the nature, position, and the size of the image. See, for convex lens, the focal length is always positive. So we have to take f as positive 10 centimeter because they have given that. Okay. Now the object distance, if you look at this rough diagram which we have written, if you place an object somewhere here, it is along the negative x-axis. So they say object distance is 15 centimeter. So you have to say u equal to minus 15. Okay. Then they have asked what is the v, that is what is the image distance, and what is the magnification. Okay. Again, utilizing our lens formula, 1 over v minus 1 over u is equal to 1 over f. We want v now. So 1 over v is equal to 1 over f. If you send the minus 1 by u this side, you will get 1 upon u. Okay. Now what is f? F is, we have said that f is positive 10. And what is u? U is minus 15. Substituting it, 1 by 10 minus 1 by 15. Okay, 10 and 15, 30. Okay, so 10, you know, if you want to make this denominator as the LCM, you have to multiply the numerator by 3. If you want to make 15 as 30, you have to multiply numerator and denominator by 2. So we do that and we get 1 over 30, which means 1 by v is 1 over 30, which means v is 30 centimeter. So the image is formed 30 centimeter along the positive of the x-axis. So that's what it means. Okay, and magnification is v by u, that is 30 divided by minus 15, which is minus 2, which means this image is real, it is inverted, and it is enlarged by 2 times. Okay, that's why minus sign is there, that is why it is inverted. Okay, give the formula for power of the lens. The power of the lens is always equal to 1 upon the focal length. Okay, remember that the power of the lens is 1 upon focal length. Okay, now the power units is called diopter. Okay, it is 1 upon meter or meter inverse. Okay, focal length is in meters, then the power will be in diopters. Diopter is meter inverse. Remember that. How to compute the effective power of lenses placed next to each other? See, if you place one lens again next to each other, for example, if you place 2 convex lenses next to each other, how do you calculate the effective power? The effective power is calculated by adding the powers of the lenses. Suppose you have 3 lenses next to each other, you just add their powers to get the effective power. Okay. Next question. Convex lens forms real inverted image of a needle at 50 centimeter. They have given the image is real. They have given the it is real. They have given it is inverted, and they have given the image distance as 50 centimeter. Okay, where is the needle place? Okay, if image size is equal to object size, they have also given that the image size is equal to object size, and what is the power of the lens. Okay, now if you draw a rough a ray diagram for your convex lens, they have said that this is the image of the needle, and it is inverted, and it is from 50 centimeter along the positive x-axis. So V is positive. Okay, what is U is the question. Where should the object be placed? Where should be the needle place means what is U? And they have given magnification is -1. Why -1? Because if you place the needle somewhere straight like this, you have got the image inverted. So magnification is and they have given image size is equal to object size, which means magnification is -1. Okay, since magnification is -1, we can say that h by h dash v by u is equal to -1, or u is equal to -v. Okay, v by u is -1. So we can say that u, if you multiply, cross multiply, you will get -u equal to v or u equal to -v, which means the object has to be placed at -50 centimeter. -50 means it has to be placed 50 centimeter along the negative x-axis. Okay, they have also asked you what is the power. To find the power, you have to find the focal length. To find the focal length, you can use the length formula. 1 by v minus 1 by u is equal to 1 upon f. U is equal to 50. V equal to 50, u equal to -50. You can substitute that, right? Minus and minus will become plus. So 50 is the LCM. 1 plus 1 will become 2. So 1 upon f is 2 upon 50. F is equal to 50 by 2, that is 25 centimeter, or it is 0.25 meter. Okay, because to calculate the power, we need to calculate it in diopters, which means focal length has to be in meter. When we get focal length in centimeter, we have to convert it into meter. So it is 25 by 100 meters, that is 0.25 meters. What is the power? Power is nothing but 1 upon f, right? That is 1 upon 0.25, that is 4 diopters. Okay. Next question. Power of a concave lens is of focal length 2 meter. Okay. So since it's concave lens, the focal length is negative, right? So f is equal to -2 meter. What is the power? Power is 1 upon f. So if you take f and say you substitute it, substitute -2 for that, 1 upon -2. So minus 0.5 diopters. Okay. So this is the power of the concave lens of focal length 2 meters. Okay, and note that the power is also minus, because focal length is also minus, the power is also minus 0.5 diopters. Image formed by a concave mirror. Okay, we are saying concave mirror is virtual, erect and larger than object. What should be the position of the object? See, if you remember your ray diagrams and all the cases of the concave mirror formation, the image is erect for a concave mirror if and only if the object is kept between the pole and the focal length. Okay, so only if you keep it between pole and the focal length will the object be erect and it will be larger. Okay, so here you see the ray diagram. I have an object which is kept between the pole and the focal length. The ray which sort of is in the direction of the center of curvature, it just bounces back in the same direction. It appears as though it is coming from here. A ray which is obliquely shot at the pole reflects such that angle of incidence, which is this, okay, is equal to angle of reflection, which is this. So you can see that it is getting shot like this, and when you backtrace it, it appears coming from this point. And as you can see, the image is erect and image is larger than the object size. So for a concave mirror, for virtual and erect image, you should always place the object between the pole and the focal length. Where should be the image placed in front of a convex lens. Okay, this time we are looking at convex lens, so that image size is equal to object size. Okay, so again, if you remember all the positions, interesting positions of image formation for convex lens, if you place the object exactly at C, the ray which is parallel to the principal axis will go through the focus, and the ray which goes through the optical center will pass in the same direction, and they both will intersect here. And when the object is placed exactly at center of curvature, the image will also be formed exactly at the center of curvature on the other side. Okay, and the size of the object and the size of image will be same. So if image size is equal to object size, then the object has to be placed at C, the center of curvature, for image size is equal to object size, as shown in the figure. Okay, next question. No matter how far you stand, the image appears to be erect. Which mirror can it be? Okay, so as you have studied before, if you have a flat mirror, then the object, the image is always erect. And for the convex mirror also, convex mirror, no matter where the object is in front of the mirror, the image is always diminished and it is erect. Okay, so either it can be the flat mirror or it can be the convex mirror.